Thank you for having a look at engineering at University of East Anglia today. My name is Catherine Coventry. I hope that I can show you the exciting program delivery we have here and that you'll consider joining us in the future. So we have a range of programs that we offer here at University of East Anglia. We have our energy provision, which were our flagship programs back in 2013, and those programs are very much attracting those students who are very conscious about climate change and looking to make a difference. And then we have our integrated engineering themes from general engineering, engineering with a mechanical pathway, engineering with an electronic and electrical pathway, and also we have the facility to enable students to take a year in industry. And as you see, our pathways start from foundation year degree and also extend to integrated masters. If we consider our module delivery, we can see that across the years we have a wide range of modules. So you can see our modules between the second and third and fourth years. Our first year is very interesting here because our first year really focuses on integrating the delivery of engineering education, making sure our students who maybe don't have a friend or family member who is an engineer, but we want students to be able to understand the choices they may make going into the second, third, and fourth year about the pathway they pursue. So in that first year, we make sure that they have some experience of the discipline of engineering and the sub-disciplines of engineering so that they can make a better and informed choice moving forward through their academic careers. You'll see that the modules that are on options that are open to our students, they tend to remain the same generally. What does change though, here you can see in the mechanical pathway, is the core and optional delivery. So here in the second year, you'll see that dynamics and vibration is part of our core delivery, while if we have a look at if we consider the electronic and electrical pathway, you'll see here dynamics and vibration has become an optional module within that pathway. So students can choose to take this module, but it's not part of the core delivery for that particular program. So while the option's still available to them, they have other options that they could also consider. If we look at the energy pathways, so we start here with energy, engineering bracket energy, and we go on to energy and environmental management. And you'll see here that the module offering becomes a little bit more expanded to incorporate our specialism in environmental sciences here at UEA. So we go beyond our school to use the expertise of another discipline, in this case environmental sciences, to expand our offering and really connect us to a particular pathway that is open to them. Irrespective of the pathway you take or the module options you make decisions to pursue, what is very important is that design becomes a very much an underpinning feature of engineering education across all years of the degree programme. And hence you'll see that there are various opportunities for design practice throughout our programmes. The need for engineers to understand what it is like to work with incomplete data sets in real engineering environments where there's a host of complexity is really important to making sure that they can perform when they graduate from UEA. And this is what we do in exposing you to design education right across your degree programme, making sure you understand and you become very comfortable working with that degree and level of uncertainty, complexity, and risk. So the ways in which we encourage and engage you in your learning are varied. This is an example of output from our first year innovation task. In this task, on the first day of our first year's education, we introduced them to the managing directors of companies like UK Power Networks, which is one of the biggest electrical distributors in the UK. And also last year, we introduced them to the technical manager and engineer at Kettle Chips. Kettle Chips is a snack food producer. And what we wanted to do was encourage our students to innovate and come up with a solution to problems that hadn't even been envisaged by these organizations. So our first year students, who are very much used to sitting high school exams, looking at the question booklet and then marking themselves against the solution booklet, had to suddenly go into environments where they had to look at all the complexity of those environments, look at what these organizations might do better, and then come up with an idea that they could then sell to these organizations as a potential way of reducing their energy consumption, of improving their safety record, of saving them money. So this is what our students get involved in very early on. And these are the output, these posters are the output of that 3 weeks of exploration. In regards to last year's activity with Kettle Foods, we have here a particularly good piece of research that was done by our first year group, which looked at mycelium, which is a fungus grown from the shaving of potatoes. So they explored what Kettle Chips did in their production of snack foods. They used the waste from that production process, the potato shavings, and they grew this mold from that waste. And this mold can be used in fabrics for insulation, for example. So in using the mold and using the waste product, they could make insulation that could then insulate the building, thus saving them energy. So this is a particularly good piece of research by our new first year students last year. So the other ways we get you to learn, we make sure that your digital literacy skills are very well honed. And we do this early on because if you want to go into and gain some summer work experience, it's particularly useful. Digital literacy skills are a very good way of enabling our students to become useful to engineers in practice over the summer periods. And here we have Mr. Cox, who is from Autodesk. So while university professors do a lot of research, they don't tend to keep up to date with the revisions of packages that are going on in an almost daily basis. And so what we've done is we've liaised with Autodesk, making sure that we use the most and train our students in the most up-to-date engineering packages by bringing them in to deliver a session for us. And here's our first years again, engaged in that particular delivery. Other things that we do in terms of packages are looking at MATLAB, looking at SolidWorks to do some finite analysis. So here you have some here looking at the stresses around a plane, for example. Always improving your digital literacy because engineers have to work in a digital world. Other skill acquisition is also important. So it's important, many of the first conversations engineers have when they are looking at design work, for example, comes from starting to pick up a pen and sketch it on a piece of scrap paper, on a napkin. And in that way, ideas are born and concepts are established. We also look at wider skill sets depending on the natures of activities and design work we're doing. And here we have a couple of our students doing some surveying tasks on our beautiful campus here in Norwich, really learning new skills that are beyond the curriculum in their free time, supported by lecturing staff. I was speaking earlier about the importance of design and design work for engineering students, and making sure that they are really comfortable with that open complexity of design challenges. And here is a particular challenge that our second years have been involved in, that is the design of a vertical farm. A vertical farm is a concept that originated from about 2010, looking at the growth of produce within aquaponic beds, water beds, um, saving distribution costs from growing fields outside of megacities. Those are cities beyond 10 million people. So here our students were involved with having to design the building, having to design the mechanical growing beds where the produce would grow before they were harvested, and then looking at the electronic and electrical means by which to monitor and harvest that particular crop within these buildings. The energy engineers were also focused, obviously, on the energy use and energy consumption within the buildings and what sort of facilities would be needed to encourage growth and maximize produce. And you can see how this really links to things like the Sustainable Development Goals, where society, and one of the challenges for society is looking at food production as we progress forward in time. So these are the sort of wide open challenges that students get exposed to, and they are highly creative. You can see here that we're working in groups. We're supported by members of staff. So we've got staff supporting the students within their learning, making sure that they understand and all the issues around the particular design work they're doing, and they can talk through and explore those issues with a tutor. We're very interested for our students to get involved in a wide, diverse, rich curriculum of activity, and the Engineers Without Borders Challenge allows us to, gives us a vehicle to enable us to do that. Here the students engage with communities very different from their own, where they're looking at how the community functions, what resources does it have, which tend to be limited because of the actual communities that are selected for this challenge. And how those students may impact by finding ways and solutions linked to improving sanitation, improving water provision, improving digital access or energy use. And our students will explore those themes within these communities to come up with ideas and designs that may help and benefit those community areas. So you can see here that for any of our groups that are chosen and selected by the Engineers Without Borders assessment team, they may go to London in the summer and exhibit their particular solution. And here's a couple of students in the middle of the picture who are doing just that, showing their poster, demonstrating their ideas to an audience, and explaining and justifying how they've come up with these ideas. For any team that's particularly successful in this morning presentation with the posters, there is the opportunity to go through to the afternoon and actually do a presentation in front of the audience, giving further details on that particular solution that they've generated over their engagement with the project. So here we have an example of really diversifying that learning experience again through design, build and tests. Engineers love to build things and they love hands-on activity. And our first years here are no different to most of our engineers. And here they have developed and built and designed robots that can sense their environment and programmed the operation and programmed their movement using an Arduino. And so they've many of them working in groups, they've come up with these designs. Many of them have also 3D printed component parts of these designs. So we've got some printing of 3D printing of wheels. And then on the other hand, we've got students being very creative and using very domestic everyday objects like a ping pong ball as a front wheel to negotiate, to allow this robot to negotiate its environment. We also have students utilising their Lego to build a garage. Again, this is an Arduino project where the Arduino is programmed so that the garage door gets lifted as the cars approach. A light goes on inside the garage and the garage door goes down. So it really shows and enables students to demonstrate their learning and their creativity. So all these learning experiences amount to a really rich curriculum that enables students the confidence to tackle new subject areas in the way that's important to them. And never more is this demonstrated than when students start to select their final year dissertation projects and they start to really articulate what is important to them. And so here you see a selection of topics and titles that students have chosen that link to their personal interests. And you can see that there are students who are very much interested in biomedical engineering. There are students interested in manufacturing activity, students very much considering the state of the nation and looking at the impact of Brexit, linking that to the renewable energy sector, or again wanting to design and construct by the process of consideration of a wave energy capture device. And this is where the students really get to influence their degree pathway, because this is where they get to choose what they want to learn and how they want to go about learning it. And after they've explored their projects, towards the end, we get them to produce poster, like you can see here now. And these posters help our students to showcase what they've done and what their learning is. And we often bring in industrialists to talk to the students about that learning and about what skill sets they've gained through the project. And industrialists are never more amazed about the breadth of interest that our student body have based on their experiences at UEA. I was talking earlier about how our students get involved in a lot of design work, and this is an example of the final year of the master's, integrated master's program, where they're getting involved with design work linked to real life learning situations. So by partnering with a company, in this case it was a laundry provider, who used a lot of energy through the heating and then the wasting of hot water. This particular organisation wanted our students to come in and look at how they might save energy and gain efficiencies of their operation. They also had just developed and just acquired a new digital dashboard, and our students, being much more of the digital age, were able to really look at the data and the output from this dashboard and see how the organisation might explore those big data analytics in order to gain the efficiencies that it was looking for. So in this way, our students really get to understand how engineering links to society and links to the challenges of society and organisations that are operating. The following year, we partnered with the Snetterton Biomass Power Station to look at the design of the power station and support it through looking again at efficiencies and energy efficiencies in the production of the building itself, considering the building physics, considering the energy usage, really looking and using the holistic skills that our students had developed through the 4 years of their degree programme. Having had these device learning experiences, it's really important from that point that we connect our students to industrialists and to their future employers and giving them experiences within industry. Site visits enable us to do that. Students see what industry looks like and then see what they might aspire to as their roles as engineers within industry, whether they're looking at a paper manufacturing plant or a service vessel for the offshore wind industry. We have a range of companies that we engage with regularly, and we also have a very diverse way in which we engage with those companies. So, not only do we do a year in industry, which many universities do, but we offer the students the opportunities to replace modules in the second and third year with after the second and third year, sorry, with placements within industry, 10 weeks placements where students can go into placement, fulfill an agreed learning contract that we have established with that employer, and then having presented and produced work on their learning experiences, they can be credited with that learning as part of their degree, and that's really unique. There's also the opportunities to do internships, and the way in which many of our students will acquire these positions is through something known as Select, which is a scheme to help place students within. So the ways in which we help our students connect with our employers are through events such as Select, and here we see the activity that took place this year where employers came into the University of East Anglia to meet and interview our students in short, sort of 15-minute periods. A bell would ring, and then the students would rotate to another table. If students and employers wanted to carry on those conversations further, the employers could potentially invite them back for interview to link to graduate positions, to summer internships, whatever they had on offer. So you may have chosen to come in and do a year in industry, or you may have decided that at some point through the first or into the second year of your degree. And either way, there's lots of flexibility there that you can make decisions later on. There's no requirement that what you come in with in the first year has to remain your program choice. So doing a year in industry is advisable for anybody who wants to develop their employability skills. This is a 36 to 45 week placement after second year of your degree program, and really enables our students to gain real professional skill in the workplace. The other ways that we encourage our students to showcase their abilities is through mingling and networking at the South North Sea Conference. In this particular instance, one of our students got up at the stage to ask the presenting panel questions, and not all our students will be ready or feel ready to take that step, and we won't force you, but we will give you the opportunities to do so that you can showcase your talents to the industry with which you want to get involved. Connecting you to industry is one of the ways we hope to help you to succeed. Of course, your success will also be supported by one of our academic advisors within engineering, and they'll help you with module choices, career choices as you progress through your studies. Why University of East Anglia? Well, we have a real innovation in our programme delivery to create a new breed of engineers for the societal challenges of the future. We have excellent industrial support that enables site visits, internships, and years in industry to be offered to our students. We also have a program that really develops your skill set, whether they be technical skills, soft skills, transferable skills. And we also have our strong engineering design theme, implementing and embedding commercial awareness to make you function in industry. Thank you for your interest today. I hope to see you soon.